I think we need to have a clean version of this. Let me I'm looking for a periodic table. Okay. Now, our department has two periodic tables. One looks like that up there, and the other one looks something like this. The difference between these two is this has the name of the element in it. That one doesn't. So when you take 1A or 3A, you're going to be asked to know not all of them. It depends on your instructor, but some of the elements, names. I believe in a smartphone that you can get in 3 seconds, the name of anything you want. So I use this one in this class. So it depends on your instructor for your next chemistry class. Okay, and this is kind of an older one because it goes, these are all filled in here. Goes up to 118. And also there are two versions of this, and it depends on where this is. It's either there or here. This is the one we're going to use in here. And it has to do with something called electronic configuration. And we're going to get into that in Unit 3. Okay, so let's talk about the periodic table. Okay, there were two individuals about 150-ish years ago that were very organized people. One is in Russia, and I forgot where the other one is, in Eastern Europe someplace. One was a geologist, the other was a physicist. And the geologist put this together before the Russian did. But the Russian is given credit for it because he published it. The geologist didn't. So, any of you are interested in graduate school, publish or perish. Okay, so let's look at the organization here. So they had a bunch of elements at the time that are different. And they came up with, for each one of them, they discovered chemical characteristics for each one. And they said there's got to be some way these are related. So what they did is they put a big long line together where the molar mass, which is how much they weigh, and we'll get into that in detail, just in a long one-dimensional row. It's like a train. And then they noticed that every now and then, the chemistry of that element was the same as a prior one. So they went along and went, whoa, this guy and that guy are the same chemistry-wise. They look the same. They behave around acids the same, around alkaline materials the same. So their chemistry was almost identical. And we're also going to study why that is, by the way. So what he did was he took this now row here and started it like this. And then all of a sudden, it started to repeat again. So they took that over here. And that's how the two-dimensional shape of the periodic table was developed. And that's where the term periodic table. So the periodicity is in the chemical characteristics. Repeat. Every time it repeats, the line is cut and brought underneath the other one. That's similar. Okay, so does that make sense? They were very organized. I'm sure their sock drawers were very organized. You pull them out and they're all in a row. And okay, so this is the almost modern periodic table. And we've got, now you're gonna have to know parts of this. The way this is organized, these are called groups. And a group is a group of elements that have similar chemistry. So we're looking at hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. Those all have the same chemistry. They don't weigh the same, but the chemistry is the same. And the name of that group is let's see here. To the alkali metals. And that's called group 1. Okay, and these are the ones you have to know. I've only chosen 4 of them out of a whole bunch of them there. The next group over is called the alkali earth metals. And they're very closely related, so by the name, but they're not totally related. Okay, and we're going to jump over here to the far right. Those are the halogens. Those are the noble gases. Okay, so it's really important to understand that chemical groups have the same chemistry. Now, you've just learned this in the last 5 minutes, right? Let me show you how useful that is. During an atomic blast, where is it? Strontium becomes radioactive. There's a lot of strontium thrown up in the air in terms of fallout, and then it comes settling down on fields around the bomb site. Now, again, keep in mind groupings now. Notice strontium is located underneath calcium. What goes on in our body inside bones? That's where blood vessels are made. Inside the marrow of a bone. Now, the problem is it needs calcium to do that. So that's why they always say, drink your milk or whatever to get calcium to build strong bones and all that good stuff. The problem is if you have radioactive strontium around, strontium acts just like calcium. And one of the problems with radiation sickness is you have something called extremely bad anemia and extremely bad, what's the blood cancer? Leukemia. That is a frequent illness for radiation sickness, this leukemia, because the strontium gets inside your bones because your bones absorb calcium. Well, it absorbs strontium just as well. It doesn't use it much, but it still absorb it. Yeah. So remember, you guys, Ferguson's hard of hearing. Well, remember I said drives down in fields? Yes, the cows eat the grass that has the strontium on it. Cows produce milk. What do they always say about strong bones? Drink your milk because it's got calcium in it. So that's the route. They call that a vector. So who has seen the movie Chernobyl? Not the movie, but the series. Anyone? Yeah. Think about all that. In the first episode, remember the deal about iodine? Remember the woman physicist when they came to visit her really early on? She gave everyone bottles of iodine, sodium iodine. The reason is that your body takes up iodine. Your thyroid needs iodine. Like when you buy salt, it'll say there's iodine and non-iodine salt. And on the non-iodine salt, it says something about iodine being a nutritional importance or whatever. So if you're around any kind of radiation, what they do is they give you iodine tablets, and the iodine tablets saturate your thyroid with non-radioactive iodine so that it won't absorb the bad iodine. So if you were ever given a bottle of iodine tablets, beware. And again, it's in that same line. What do they make body parts out of? Like you get a knee replacement or shoulder replacement. Yeah. Aluminum. That's one. What else? Titanium. Una más. Stainless steel. Quizás dos más. Maybe two more. Keep going. What's the most common element in your body? There's two, carbon and hydrogen, okay? So look on carbon. See where carbon is located? Right there. What's underneath carbon? Silicone. That's why they use silicone frequently, along with aluminum and titanium and stainless steel. They use that because it's so similar to carbon, periodic table. Okay, I go to the doctor. Ferguson, your blood pressure is too high. You got to get it down. He says, cut out salt. Salt, as you probably already know, sodium chloride is the formula. Okay. Okay, the chlorine is what gives it its salty taste. So I go to Raley's and I go over to the spices. And I'm looking up and down, and here's the salt. Oh, put it back. You can't buy it, you know. And I said, is there a substitute for salt? Who's heard of light salt? Some of you have. Light salt is potassium chloride. Potassium chloride. So potassium's right underneath sodium, hence potassium's chemistry is like sodium. So it tastes salty because it's got the chloride part, but it doesn't have the sodium, which raises your blood pressure. And it's an okay substitute. I just use less sodium chloride. But anyway, that's why it's sold as light salt, because the potassium is underneath sodium and it acts the same. Okay. So knowing that group concept is really cool because it very, very useful. Okay, so you need to know those 4 groups. And these are called periods or shells. And there are 7 of them. And I like to use shells over periods because we're going to get into electronic configuration and you're going to be looking at shells and subshells, orbitals, etc. So, so periods go across. And there's only trend you can say about periods is as they go across, the atoms get smaller. In period 2, fluorine is smaller than oxygen, which is smaller than nitrogen, smaller than carbon. It doesn't matter what period you're on. And there are no names for periods or shells other than numbers. Shell 1, 2, 3, 4, 5, 6, 7. Okay. Now, in general, periodic table is broken up into 3 parts. Okay, the left of the squiggly black line is called metals. And metals have characteristics. They're shiny, they conduct electricity, they're bendable. And guess what the opposite of metals? What's the name of that? It's a hard one now. Non-metals. And non-metals do not conduct electricity. They're dull. They're not bendable. They're just exact opposite of metals. And then there are the transition metals in between metals and non-metals. Those are called metalloids. And those are the elements that border the black squiggly line. So those guys there. Now, most everything are metals. Most everything are metal. And they form positive charges, positive ions, where the nonmetals form negative ions. And when we get a metal and a nonmetal together, it's called an ionic compound, like salt. Sodium is over here, it's a metal. Chloride over there is a nonmetal. So sodium chloride is a ionic compound. So metal plus nonmetal. We're going to talk about this in extreme detail in Unit 3. Okay, so that's what I wanted to cover today on the periodic table. So you need to know the organization. So I'm going to give you a blank periodic table on the test, test 2, And I'm going to ask you to label these parts. So the four groups, metals versus non-metals versus metalloids, the names of the four groups. So are there any questions about periodic table organization? Now we're going to keep refining this as we go. Yeah. Yes. Well, the video is, and the periodic table is under files. And every test from now on, I'll give you a periodic table. Okay, so I'm going to end this here.